Okay, Wildcats, let me get to here. We're going to be looking at the 1.2 characteristic functions assignment tutorial. So let me click on there to view it. All right, there we go. All right, number one, the graph shows a function that models the value V in millions of dollars of a stock portfolio as a function of time in months over an 18-month period. To the nearest integer, on what interval is the function increasing? Okay, so it's increasing from 0 to 5, okay, and then it's decreasing from 5 to 16, so that's right here where it's decreasing 5 to 16, and then it's increasing from 16 to 18. Okay, let me hide that. Check answer, correct. All right, let's take a look at number 2. The graph shows a function that models the value V in millions of dollars of a stock portfolio as a function of time t. Let's scroll this down. Identify any maximum values and minimum values, okay? The maximum value is right there. So when t equals 5. So let's look at the answers. That could be correct. That's wrong, wrong, and wrong. So the only option so far is A. Let's make sure that the value is correct at 5. 6.7, that seems logical. And a minimum occurs at 16, which looks good in 1.1. So the answer is A. All right, let's take a look at number 3. Graph shows a function that models the value V in millions of dollars of a stock portfolio as a function of time t in months of an 18-month period. What are the function's domain and range around the values to the nearest whole number? So domain is from here to here. And here. Okay, so from 0 to 18. Okay. Now the range is the lowest point to the highest point. So the lowest point's right here at 1. So it's from 1 to 7. Okay. Check answer, correct. Okay, number 4. All right. The table values give the probability of getting all 2s when rolling a number cube n times. Is P n increasing or decreasing? Complete the explanation. As the number of rolls increase, P of n is always decreasing. And the reason being is these are getting smaller. Okay. This implies that the more times the number of cube is rolled, the less likely that is that every roll is a 2. All right, check answer, correct. And number 5. The table of values gives a probability of getting all 5s when rolling a number cube in n times. What is the n behavior of P of n? Complete the explanation. As n is increasing, P of n is now approaching infinity because these numbers are getting bigger. It's approaching 0 because they're getting smaller. All right, correct. All right, question number 6. The table shows some values of a function on which intervals is a function's average rate of change positive. Okay. This is where we're going to need a little bit of work, but let me first off address rate of change. Rate of change is m, which is slope. Okay. So we need to find the slope of each of these. Okay. So first off, let's look between 2 and 3. So that's here. Okay. So A, let's find the slope. So m equals 75 minus 50 divided by 3 minus 2. Well, that equals 25, and that's positive. Okay. So A is definitely an answer choice. Okay. Now let's just go down A, C, and E first, and then we'll do B, D, and F. So now let's look at C. Okay. Now C is between 0 and 3. So I'm actually going to mark these out so I can look at just those points. Okay. So C, M equals 75 minus 60 divided by 3 minus 0, which equals 15 divided by 3, which is positive, so answer choice C is correct. Okay. All right, now let's look at E. M equals, so I'm doing my best to try to make as much space out of this as I can. M equals, let's see, we're looking at between 0 and 1. So looking here. Okay, so that's 85 minus 60 divided by 1 minus 0. Let me give myself a little bit more space. Well, that's 15 divided by 1, which is positive. So far, A, C, and E have positive rate of changes. Okay. All right, now let's take a look at B. Okay. Okay, B says between 1 and 3. So I'm going to mark out here and here so I can look at just 1 and 3. So then that's M equals 75 minus 85 divided by 3 minus 1, which is negative 10 divided by 2. We don't need to simplify. All we need to know is that negative, so it's not B. Okay. Now let's look at answer choice D. So then D says between 0 and 2. So mark out this and this. Okay, so then that's 50 minus 60 divided by 2 minus 0 equals negative 10 divided by 2. It's negative, so it can't be D. And let's look at the last one. Let's look at F is 1 and 2. So we're looking at here. Okay. So then F is M equals 50 minus 85 divided by 2 minus 1. Okay. And then that's 50 minus 85 is negative 35 divided by 1. That's negative, so the answer is not F. So the answer choices are C, A, C, and E. Check answer, that's correct. On to number 7. Well, that's weird. I thought that this was sticking with the problem and not page, but get rid of all of that. Give me a second. I should be able to, if I spin this eraser around quite a bit, get rid of that previous work. Okay. All right, now let's take a look at number 7. All right, what is the function's average rate of change over interval? Now you can also find rate of change, which is slope, okay, using rise over run. Okay, so rate of change is m, which we know is slope, which is rise divided by run. Okay. All right. So now let's look at A. The average rate of change at interval between x is negative 3. So we got to find the point when x is negative 3 and x is 2. So x is negative 3 is this part right there, and x is negative 2. Oh wait, That's wrong. I looked at the wrong point. Sorry. Negative 2 is right there. Okay. So rise over run. So we go up 1, 2 to the right 1. So that's 2 divided by 1 equals 2. The average rate of change over the interval negative 2 and 1. So x is negative 2. Okay. And x is 1. So right here. Okay. Oh, whoa. I went blank there. X is positive 1. So the point's right there. Okay. So now we do rise over run. So we go down 1, 2, 3, 4, 5, 6. To the right 1, 2, 3. So the rise over run is 6 divided by 3, which is 2. Okay. Let's take a look at the next one. All right, when x is 0, so x is 0, there's a point right there. And when x is 1, there's a point right here. Okay, so rise over run, we go down 1. Let me erase this. So it's negative 1 to the right 1. So the slope is negative 1. All right, average rate of change over the interval x is 1 and 2. So x equals 1, point right there, and x equals 2. Okay, so rise over run, so we go up 1, 2, 3, 4 to the right 1. So that's 4 divided by 1. So that's okay. Let me erase this. Okay, now it says the average rate of change over the interval x is negative 1. So x is negative 1, so this point right here, and x equals 0, this point right there. Okay, so then we go down 1, 2, 3 to the right 1. So negative 3 divided by 1. So that is negative 3. All right. Now, last one, the average rate of change of the interval when x is negative 1 and x equals 2. So rise is 0, and then run is 1, 2, 3. So 0 divided by 3 is 0. Rate of change is 0. Check answer. Let's take a look at why. Part B is incorrect. The average rate of change of the interval is, and I'm glad this popped up because this is what I've been using. It's a change in y over change in x. Okay. So that's good. Let's look at the answer choice B, see what mistake I made. Okay. All right. So B says when x is negative 2 and x equals 1. Okay. So let's double check the math here. So we go down 1, 2, 3, 4, 5, 6. Negative 6 to the right 1, 2, 3. My mistake was that I put a 2 and it should have been a negative 2. Let's check answer. Correct. Right? And you're going to see me, by the way, in videos that if I make a mistake, I'm going to go with it. So if I make a mistake, you might make a mistake, and we can learn together on some of those, okay? All right, let's look at question number 8, okay? And that's where the number just popped up, okay? All right, on what intervals are the function values positive? The graph is above the x-axis on the interval. So this is negative here, this is positive here. And it's all separated by the x-axis, okay? So the graph is above the x-axis on the interval x. Oh, they're using the word above, but negative, positive, same thing. So I can actually, if you want, let me see, above, below. Okay. All right. So it's above the x-axis between, it looks like -1 to -1 to negative, so -3. Oh, yep, no, -3 and 1. That's correct. And then it's also above when 1, 2, 3 infinity, so x is greater than 3. All right, that's correct. Question 9. All right. On what intervals are the function values negative? Okay, so that's where the negative comes in. So here's negative, positive, and it's all separated by the x-axis. Okay, so the graph is below the x-axis on the interval, so it's below at -1 to -3. So hold on. They're doing this section first. So between 1 and 1, 2, 3. So 1 and 3. And x is less than 1 to -3. Correct? All right, let's look at question number 10. All right, what are the zeros of the function? Zeros are the x-intercepts. And they are these points right here. So this one, and this one. Okay, so x is -1 to -3. X is 1, and 1, 2, 3. Answer correct. All right, and we're actually going to skip questions 11, 12, 13, 14, 15, and we're going to start on 16 and do 16 through 20. The model A equals 0.25t plus 29 represents the median age A of females in the United States as a function of time t in years since 1970. Predict the model median age of females in 2004 to the nearest 10. Okay, so 2004 is years after 1970. So if you add 30 to 1970, that's 2000. Add 4, that's 34 years. Okay, so we're going to put in 34. Okay, let's use this calculator. So that's 0.25 times 34 plus 29 equals 37.5. They said round to the nearest 7 or 10, so that's 37.5. Now, 2023 is, well, if you add 30 plus 23, that's 53 years after 1970. So 25 times 53. So let me clear this. Find the clear button. So then that's 0.25 times 53 plus 29 equals 42. And you round to the nearest tenth, so the 5 rounds to 3, so 42.3. And let's check answer. That's correct. All right, 17. Anthropologists who study skeletal remains can predict a woman's height just from the length of her humerus, the bone between the elbow and the shoulder. The table gives data for the humerus length and overall height for the various women. Using a graphing calculator, find the linear regression model in this domain into the values of the slope and y-intercept to 2 decimal places. All right, so to find that, I'm actually going to, don't need that screen, I need, here we go. I'm going to go to desmos.com and I'm going to type those values in. Second, I have those values in the paper book, so give me a second to get those values. Here we go. Make sure I have the right numbers aligned with this. If I can get to my tab. All right. Now if I can get back to Desmos. Here we go. Graphing calculator. What I need to do first is I'm going to go to here, and there should be a linear regression option. Find that. I found it before. Find. Trigonometry, conic, polar, transform, statistics, linear, statistics, linear regression, that's what we want. Graph. Alright, so now I need to change the value from this table to 35. This is the general lineup. Alright, so 35, 27, 30, 33, 25, 39, 27, 31. Alright, and then 167, 146, 154, 140, 180, 149. Apparently messed up right. Let me see what I'm missing. 35, 167, 27, 146, 30, 51, 54, 33. That's where I missed it. 165, 165, 25, 140, 39, 180, 27, 149, and then 155. Right? Now what's it say? It says if you press and hold on the icon in the table, you can make the table columns movable, drag the points in the graph to what's the best fit. Okay, let's see. Here's the equation we need. So the equation, they're saying M is 27.5 and B is 71.9. Let's write those down before I change the tab. So 2.753 is M, and B is 71.97. Okay, let me go back to here, find my tab. All right, H, which that's your M value, which is, and they want it to round to the nearest 2 decimal places, so 2.75 and plus 71.97. 71.97. The in centimeters, H is the overall height in centimeters. The shortest length of humerus given in the table is, so the shortest height in the table, give me a second, I'm looking at it, I'm going to say 140. Oh, it's right there. I'm sorry, I'm looking at my book. But 140 seems to be the smallest number. And the longest is 180. The domain, so the domain regression model is, second, so it's between the shortest and the longest. So 140, the x value is 25, and the longest 180, x value is 39. Oh, no. Oh, there's more to this problem. That's why. All right, predict a woman's height from a humerus that is 34 centimeters long and tell whether the prediction is an interpolation or an extrapolation. That's weird. All right, L equals 34, H equals 2.75, which, interesting enough, these numbers line up with what we have, so that's correct. So 34 plus, and so that's where we use our calculator. So down before I move the screen. So 2.75 times 34 plus 71.9. Okay. Well, let's see. So we clear this. 2.75 times 34 plus 71.97 165.47 they want. I assume 2 decimal places, 165.47. And would be, so the woman's height to the nearest centimeters would be 165. That's 34 is in the domain. 34 is in the domain. The prediction is in, and I honestly don't know what interpolation is or extrapolation, but I'm going to pick one and we'll check. Part 2 is correct. Interesting. So it isn't an interpolation. I recommend Googling that in an online dictionary, looking that up, and I'll do the same. What they're saying is something's wrong in domain. Let's look at the graph. Why are they saying the domain is wrong? Because I'm almost, see, oh, I think something got changed here. And apparently it doesn't want to let me change the question, but these are the numbers wrong. It should be the height values, and I don't know why those are there, okay? But that's an easy fix on your part, okay? So let's move on to the next question. So that was, I believe, question 16. No, that was question 17. Let's move on to 18. All right, hummingbird wing beat rates are much higher than those in the other bird. The table gives data about the mass and the frequency of the wing beats for various species of hummingbirds. Okay. Using a graphing calculator, find the linear regression model and enter its domain into the slope and y-intercept of the regression model to the decimal places. Okay, so this is again where we're going to need the decimals calculator, which if I can find it, exit that, go back here to statistics, linear regression, open graph, and so table 3.1, 2.0, 3.2, 4.0, 3.7, 1.9, and 4.5. 60, 85, 45, 55, 90, and there we go. There's our information. So the M value is negative 19.1434, and B is 121.97. All right, so let's go back to here if I can find my screen. So F equals negative 19 points, and they want the 2 decimal places, so 14 plus 121.97, where M is the hummingbird's mass and F is the frequency of the wing beats per second. At least the least mass given in the table is the least mass is 1.9, and the greatest mass is, let's see, it's like 4.5. The domain, I'm going to say, is between the smallest and the largest. I think that's why they asked that question, 1.9 and 4.5. Check. We're good there. Now predict the frequency of a wing beat for a hummingbird for the math of 15 grams. So the gram M is 15. We're going to plug in 15 into here. We're going to use our calculator. So let me get this comes off the side. So perfect. Clear. So 15. Oh, no, I'm sorry, negative 19.14. There should be a times button. Time. No, that's weird. Oh wait, no, that's right. Negative 19.14 Negative. I thought I put a negative in there. Negative 19.14 times 15 plus 121.97. So it's 409.07. So 409.07. Complete the explanation, the reasonableness of prediction, and what, if anything, is wrong with the model. See, oh, a negative wing beat. Yeah, because you can't have a negative wing beat. Makes no physical sense. So the prediction is not reasonable. There's nothing wrong with the model of the prediction, which is in. Again, we have to look this word up. It's based on the value of m that's found for outside domain model. The model simply doesn't account for hummingbird with such extreme mass. Check your math. You calculate the incorrect frequency of the wing. Check my calculator. I disagree with that. I just think it's a number issue. Oh, I forgot to fill this in. 409. That's probably going to happen to y'all. We forget to fill something in. Check. Math to calculate the incorrect frequency of the wing. Let's see if they want 409. That's what they wanted. I disagree, and I think that's just something we have to look at what the number is, what kind of number they want, what decimal place they want. But I believe that's correct. We could check our math again, but I'm pretty sure that's correct, and I can do that. Let's do that real quick. Negative 19.14 times 15 plus 121.97. Oh, apparently, no, I guess I was wrong. So that should be the number that goes in there. I don't know how they correctly typed that in, but there you go. So lesson learned, I should have double checked my math before I submitted, but you can correct that. All right, but nonetheless, let's move on to the next question. All right, 19. A student calculates a function average rate of change on an interval and find that it's 0. The student concluded that the function is constant on the interval. Complete the explanation of the student's error. The average rate of change on an interval uses only the student calculates a function's average rate of change on an interval and finds that it is 0. The student concludes that the function is constant on the interval. Complete the explanation of the student's error. The average rate of change on the interval uses only the. Let's try endpoints.
Good morning, Temple High School. It's the Prize Patrol. We are now drawing for our first set of winners, and the winners are Angie Diaz, Sherry Humphreys, Andrea Terry, Brianna Rayford, Kathy Silvis, Susan Sanford, Jerry Alblinger, and Kaylin Stewart. If you guys could please come up to the front office and pick up your prizes.
All right. I didn't have this problem omitted originally, but I'm going to go back after this video and take 19 out. It's not a good question, and we're not going to go over it, okay? Let's look at question number 20. Complete the explanation of a way to obtain a linear model for a set of data without using a graphing calculator. After making a scatter plot of the data, draw a line that appears to pass close to the data points as possible. Choose the 2 points on the line to calculate its slope, m, and then substitute one of the points in the values of m into. Then substitute one of the points and the value of m y equals mx plus b to find the value of b. Then the line to find the value b, the line's y-intercept, enter the model as y equals mx plus b by substituting the values found for the, you know what, I get what they're trying to say, but again, it's just confusing trying to fill that in. So I'm going to take out question number 20 as well. So with that, hopefully this tutorial has helped you on the assignment, and have a wonderful Wildcat day.